What is H% finite method and what is P% finite method? We know that finite element basically gives us a approximate solution, and accuracy, or another word, convergence of finite element model mainly depend upon the two factors. One is that size of the element that we denote as a H, or the type of element. Okay, or you can say degree of polynomial, or other word you can say that whether you use a linear element or quadratic elements. Linear in the sense whether you're using 400 element or whether you're using 800 element. If you're using solid element, 3D solid element, then whether you're using your 800 Greek element or you're using 2000 Greek element. Okay, 2000 means you have a node inside here, so 2000 Greek element or 800 Greek element. Okay, so now basically our convergence of finite element model depend upon that size of the element, okay, and type of whether is a or whether you are using linear element, or quadratic or cubic element. Okay, now come to our H version of the finite element. So H version finite element method basically depend on that size of the element. Okay, if the accuracy of the application solutions, or you can say accuracy of that FE model increased by decreasing the mesh size, okay, while keeping the polynomial constant. In that case, we used to say that is our H version finite element method. So H version finite element method means where we are basically fixing that type of the element. Okay, so once you fix that, you will use 4-noded element. Okay, if you once you fix that you use 4-noded element, then how many number of element is required to get converged result, or whether if you're using 8-noded element, okay, and then how many number of element basically required to get converged solution. So basically once you fix that your type of the element, and you are obtaining converged solution by changing the size of that element, that we used to say that is your H version finite element method. Okay, so now if you come to a P version of finite element method, basically in the P version of finite element method, we increase the accuracy of the model by increasing the polynomial. Okay, by increasing the degree of the polynomial. Here what we are doing, we are basically keeping that mesh size constant. We are keeping the mesh size constant, okay, only by using a type of element to obtain the accurate solutions. Okay, or we can say we are fixing the H size of the element. We have initially decided that we will discrete the element, we will discrete the whole model using this number of element. Now we try to obtain our approximate solution or converge result by changing that type of the element from linear element to quadratic element to higher order element. Okay, so using this method basically where we are changing that polynomial order, okay, or type of element, that method basically we are saying that is our P version finite element method. Now one thing you have to keep in mind that for the P version finite element method, convergence basically exponential. So we are getting that our convergence result very quickly. Okay, in that case we have to use less number of element to get our converged solution. Okay, now if we see that how our H basically affecting the result. So here once we fix that your degree of polynomial will be 1. Okay, so if we try to find the error, okay, you will observe that basically your error in energy. So here in this axis basically you're talking energy. Okay, error in the energy. Error in the energy means here basically you are calculating the error of the energy. So basically we are calculating the energy for actual model, we are calculating energy of FE model, and then basically we are taking that difference in the energy and that we are basically plotting it in a y-axis. Okay, in a log normal. Okay, natural log. If you're taking the error natural log and plotting, once you plot it, what happens, you will observe that basically if you keep the fix, then your error basically changing this way. Okay, so basically here we have discussed that what is our P version of finite element method, what is our H version of finite element method. Okay, so in the P version finite element method, we change the polynomial or type of the element, then we call that P version finite method. If we change that size of the element, if we increase the number of element and try to have that converge solution. In that case, we just say that is our age versus finite method. I hope you get the idea. Thank you.